So in the last video, we saw how we could build our own Singularity containers. And in this video, I want to show you how we can take a Python script, a Singularity definition file, and a specific batch script and run code on Orion. So to start off with, I created a GitHub repository that contains these three files. It's this gres test file that I found on as an example file on the gres webpage. Then there's the Singularity definition file that we created in the last video. I call this file Singularity with uppercase S and no extension. And that's just because there is a tool called Singularity Hub that you can hook up to GitHub, and if you name your definition file Singularity uppercase S no extension, then this tool will automatically build our containers for us. But this is the same file as we had last time. And then finally I have this singularity.sh. We could rename this to be Slurm script.sh. So this script here is our instructions to Orion on how to run our code. So you see we start with this shebang bin bash line. It's a hash and then it's an exclamation mark and then /bin/bash. So this just tells, this is a very standard line that batch scripts start with. And then we have Slurm specific commands. So we say that we want one CPU. Let me turn that off. We have one. You want to run this code using one CPU. We're gonna use we're gonna have all the code on one node. And our job is named gres test. The job we're gonna have is gonna require 4 GB of RAM. Try to estimate your RAM usage as closely to the true as possible. Don't just type 100 GB because then you would take resources from other users. And then we say partition GPU. This means that we want to use a node that has access to a GPU. And in specific, here we're saying that we want one GPU. Then we want to send an email to ourselves when the job is done, or if it fails, or whatever the case may be. And this specifies that we want all emails regarding this job. And then we want here we specify the file name of the output. So whenever you run a script with Slurm, it will take all the output from your program and store that in this output file. So we keep the normal output and the error messages in the same file. So it's similar to how you would see this in a terminal window. So these, I would just recommend that you copy from the repository that will be linked here. And then you need to modify the code above to suit your preferences, and then the code below is the code that specifies how the script should be run. So we want to load the Singularity module. So this just says, hey, we need to run this using Singularity, and that's the only module you should need to load, because remember, we've contained all of our programs that we want to use inside the Singularity container. And then we want to specify that we're going to run with Singularity and GPU access. We're going to start up this container named gres test. We're going to run Python with the Python script gres test. So let me just commit the final changes here. Just gonna stage all changes. Added white space and renamed Slurm script. Like this. I'm going to push this to GitHub. And I recommend that you keep all of your Singularity, all of your projects should have its own GitHub repository. Now I store this in this Singularity Slurm demo repository here. So then go to clone, download, and then I copy this link here. So assume that you are at least familiar with GitHub from beforehand, and that you can create a repository and stage and work with that repository. And then we go to Orion. Here I'm logged into Orion. If we look at our home directory here, we see we have the first job folder that we made last time. So let's go into that, cd first job. So now we're in this first job directory. I'm just gonna remove all sif files. So do rm star.sif, because we're not gonna be using the same files. So we don't need to store them. And then we do git clone, and then the URL that, and then this URL here, copy this, and then you right click to paste it in putty, press enter, and now we're cloning everything into this repository, into this folder. So we see we have the Singularity Slurm demo folder. You can go into that folder, view the contents. So we have keras test, Singularity, and Slurm script. So we open the Slurm script, nano slurm script.sh. No. What? Oh, slurm underscore script.sh. And we see that, let me make this text bigger actually. 14 point. Yes. We see we have this line here, and we decided to name our container keras test. So I'm just marking this, and whenever you're marking text in putty, you're copying it. So I'm gonna do Singularity, arrow up, build fakeroot, and then what was the name? It is keras test.sif, and then Singularity, uppercase S. And then we're building this like we did yesterday, or no, in the last video. This takes a while. And now we see that it failed, and the reason it failed is that I need to be logged into a GPU node. So I do qlogin. No. Exit. I need to log into a GPU node, so qlogin, partition GPU, and I want one GPU. So now we see here that I'm on the GPU node number 3, and I try the same. Singularity, build fakeroot, keras test.sif, Singularity. Run this, and now it should all work. So just make sure that you've signed into a GPU node using the qlogin command we learned about in the last couple of videos. Okay, so now we see that the Singularity container is finished, is built. So now we can run our Slurm script. The way to start off with, we just exit this GPU node. We don't need to have access to a GPU right now, so do exit. So now we're no longer logged into the GPU node of Orion, we're just signed into a normal, the normal default with less resources reserved. And then we do sbatch. So you just type sbatch, and then what did I name it? Let's look here. ls slurm script. So we do sbatch slurm script.sh. Says submitted batch job, blah blah blah. And then I can do squeue, and here we see all the different jobs that are listed. Squeue. If we do squeue -u and then your username, you see your jobs. So you see we have one job ID. It's running on a GPU partition, and I'm the one running it. And if we have a look here, we see that we suddenly have this gres mnist, and then this weird thing here. And then we see this is the job ID of this job, and then this is some other identifier. This is going to take a couple of minutes. We can squeue, look at that again. Oh, it's finished already. So then we can have a look at this file here. So we do nano gres mnist, press tab for autocomplete, enter, and then we see here is the log from gres. This is the standard output you would see when you're running a gres file normally. Just gonna scroll down to the bottom. Here we see we have an accuracy of 99%, which is what we expect on the mnist dataset. Can exit here. Don't want to save anything. And that's how we run a job on gres. Now, please do read the documentation. No, this is how we run a job on Orion. Please do read the documentation. So this is on orion.nmbu.no. Here you can go to Introduction to Orion, and here is a lot more information about how you should run your code, where you should place your files. You should not have your files in your home directory, or you should not have your data set in your home directory. So there are a few pieces of information here that you should look at. And then you're ready to start your data science experiments on Orion.